Okay, in this video, Herbson's going to be moving you on to the a new thing, and guess where I got it? Got a little book from Coach Larson's room, and you're going to be working on what Trig is working on now. I think you guys are more than capable of handling it. And what you have to do is simplify these expressions that involve fractions, okay? We talked about it a little bit in Algebra 1. I don't think I really went hardcore ham on it. But now, to simplify, it's a three-step process, okay? It's just one fraction, okay? And what you need to do is parenthesize these expressions because those are actually polynomials that we're going to need to factor. So on 1, 2, and 3, you're going to make 3 new fraction lines just like that. So on your scratch paper, look at y to the second minus 25. That's 2 terms. Now, it should be obvious to you that's not a GCF, but it is a DOPS, okay? Because it's y to the second, y, 5, 5. If I recognize there's no GCF, I'm not going to set that box up, okay? Okay, so replace that with the expression y plus 5, y minus 5. That has been replaced. I've rewritten that as in factored form. Now we got 2y to the second minus 8y minus 10. Now it's 3 terms, so it's GCF t, but I recognize we have a GCF before we do the t chart. GCF 2, 8, and 10 is 2, okay? Then I go up and divide by 2, and that gives me y to the second minus 4y minus 5. Now I'm going to go to my t chart. Now there's an implied 1 in front of the y to the second, okay? So I go a, b, c, and I take 1 times negative 5, so that's negative 5. Now, what Coach Larson does is when you have a negative, you put a positive negative, because that's the only way you can get 2 numbers to multiply to a negative is if one's positive, one's negative. And he never does minus. He always tells you to add to the b, which is negative 4. Okay, so 1 and 5, I think, does the job. It's negative 4, okay? By the way, if I would add these and it'd be positive 4, I'd just flip the signs around. Okay, so we have it. Your a is 1, okay? So you can now forget about the 1, and you can rewrite the expression as y plus 1, y minus 5. Now that 2 you can't forget about. That GCF of 2 goes in front, okay? So we now rewrite this expression as 2 quantity y plus 1. Quantity means parentheses, quantity y minus 5. Now, what you need to do now is cancel cancel out the parentheses that are the same from top and bottom. So I have y plus 5 on top, but I don't have it on bottom. So y plus 5 is going to be in my answer. Okay, y minus 5, you got that on bottom, so that goes away. Now, we still have a y plus 1 in the denominator. And now I'm looking for monomial factors. Monomial factors means it's not in a parentheses, okay? We just have 2. Now, you really can't simplify a 2, so you're just going to put it down on the bottom with your y to the second, and we have simplified. Okay, next one. Make 3 lines. And again, on top I have a trinomial, and then I have another trinomial on bottom. So I just need to factor those expressions, okay? So I have 3x to the power of 2 minus 1x minus 2. And then I have 3x to the power of 2 plus 5x plus 2. Okay, it's a trinomial. So I look for my greatest common factor, then I go to my t table. Or no, greatest common factor I wouldn't even make because there isn't one. Though it's 1, so I'm not going to do it. Okay, so 3 times negative 2 is 6 negative. So anytime we have a negative, both the signs have to be opposite. And they got to add to get to negative 1 in the middle. 1 and 6, there's no way that adds to negative 1, okay? So 2 and 3, positive 2, negative 3. Well, there's the negative 1, okay? Okay, now a is a 3x squared. It doesn't have the implied 1, so we're going to make 2 sets of parentheses, and we're going to go 3x and 3x, because a is 3 up there, plus 2 minus 3. So now that stays the same, but the other one can be divided by 3, which means it goes to x minus 1. There was no GCF, so I don't have anything to put. So I go here and replace that expression with 3x plus 2 times x minus 1. Okay, and the other one, there's no GCF, so now I go to my table. Okay, a times c, that's positive 6. Now, if it's positive, the signs on your factors have to be the same. I'll start with them both as negative, okay? So I'm adding to try to get to 5 positive. Now, 1 and 6, that's negative 7, so there's no way that makes 5. Negative 2, negative 3. That adds up to negative 5. I have the right number but the wrong sign. So if I have the right number but the wrong sign, we're just going to switch both the signs, and now it's positive 5. Okay, a is 3, so we just make a double dose of parentheses. Instead of x, we go 3x, and then plus 2, plus 3. So that 3x plus 2 stays the same, and then we divide by 3, and that's going to be x plus 1. No GCF to bring down, so then I rewrite the bottom expression as 3x plus 2 and x plus 1, okay? Okay, now you have a common set of parentheses here and here. Those can cancel out, and these two are going to be in our answer. Now, I wouldn't do anything on the second line because I don't have any outside factors, okay? And that's your answer, x minus 1, x plus 1. Okay, now when you have multiplication, don't let that spook you, okay? Multiplication, you can consolidate it into one fraction and do the same thing, okay? But this is a binomial you're going to have to factor. That's a monomial, so we're just going to bring that 2 over here. And the 5x, if there's no plus or minus sign, I don't put in parentheses. I just bring it over here. There's a minus here, so there's potential for that to factor. Okay, so 6x minus 27, okay? Okay, this does have a GCF. 6 and 27 do have a GCF. The GCF would be 3, but you wouldn't put an x with it. You just factor out 3. And that becomes 2x minus 9. But it's not a dot, so that's as far as I can go. So I rewrite that expression up here as 3 and then 2x minus 9. So I put times after that 2, and then 3, in parentheses 2x minus 9. Okay, now let's look at 4x minus 18. GCF would be 2. So I factor out 2, and then I get 2x minus 9. Well, that's not a dot, so I don't do the dots, okay? So I rewrite that as 2 times 2x minus 9. So I put times 2 and then 2x minus 9. Okay, now your common parentheses cancel out, and you're not going to have any parentheses down here. Now, you got to do this up here. First off, you got to multiply the top. 2 by 3 is 6. Then 5x times 2 is 10x. Now you reduce 6 over 10, okay? That can be reduced to 3/5. So I come down here and put 3/5, and then that's the only x I have, so it's 3 over 5x. Okay, next one. This looks like a fun one. Okay, so again, multiplication means you can combine it into one fraction. Okay. Okay, so you have x to the power of 2 minus 3x minus 10. No GCF, so I go ahead and make my table. Put an implied 1 there. So I have negative 10, okay? So positive, negative, and I'm trying to add to get to negative 3. 1 and 10, that's not even 3. Positive 2, negative 5, that is negative 3, okay? A is just a 1, so that's x plus 2 and x minus 5. No GCF. So I replace that with the parentheses x plus 2 and x minus 5. Okay, now let's stay on top. Let's look at our other top one. X squared plus 4x minus 21. No GCF, so I go straight to my table. You can put an implied 1 there. Okay, 1 times negative 21 is negative 21. So positive, negative. And you're trying to add to get to positive 4. That's not even close. 2 is a decimal. Now that adds up to negative 4, but to make it positive 4, you just make your 7 positive and your 3 negative. Okay. Now your A is 1, okay, so I can rewrite it as x minus 3, x plus 7. Okay, then the bottom, you got x squared plus 2x minus 35. You don't have a GCF, so we'll put the implied 1 and do the t table. 35 negative, okay. So positive, negative, you're trying to add to get to positive 2. 1 and 35 isn't even close. And then 2, 3, and 4 are all decimals, then you get to 5 and 7. Now again, I have the same thing. I have the right number but the wrong sign, so I just make the 7 positive and the 5 negative. So then that becomes x minus 5, x plus 7. Okay, and then finally we got x squared plus 9x plus 14. No GCF, okay. So I go A, B, C. T-table, 1 times 14 is positive 14. So signs have to be the same. I'll start with them both negative. I'll just switch them if it's the wrong sign. So add equals 9 positive. 1 and 14, not even close. 2 and 7. That's negative 9, but if I make them both positive now, I'm at positive 9. So A is 1, so it's just x plus 2, x plus 7. Okay, now the hard work's done. We just cross out x plus 2. I have that on bottom. I got x minus 5 on bottom. Don't have x minus 3 on bottom. Now, when you do x plus 7, there's 3 of them, but you can only cross out 2 at a time. The other one stays. And then you get x minus 3 and x plus 7. Now, I don't need to do any analysis here because there's no outside factors. Okay, next one. So x to the second minus 2x. Now there is actually going to be a GCF here because even though 1 and 2, the GCF's 1, they both have x, okay? So our greatest common factor, we want to do 1x, okay? So I factor out a 1x, and I go divide by 1x. So it's going to be 1x minus 2. And that's not a difference of perfect squares. It's a minus, but these are not perfect squares. The x isn't even to the second power. Okay, so I rewrite that as 1x, and then 1x minus 2. Again, parenthesize where you have plus and addition or subtraction. Okay, 3x minus 6. There is a GCF. 3 and 6 definitely have a GCF of 3. We're not going to do an x on this because the 6 doesn't have it. That becomes 1x minus 2. And that's not a DOPS. So I got 3, 1x minus 2. Well, you can get these out of here. And then I have 1x and 3. 1 and 3 have no greatest common factor to reduce, so that'd be 1/3 still. And then that x, there's no x on bottom, so that x just stays like it is. So it's 1x over 3, or x over 3. Okay, 15, again, you want to parenthesize this. The other one, you don't have any plus and minus operators, so you just put that over here so it can't be factored. Okay, it's 2 terms. The greatest common factor, 15 and 24, is 3. Okay. And it's 3x because they both have x. So I factor out 3x. That's going to become 5x plus 8, okay? And that's not a DOPS, so I don't go any further. So I rewrite this expression as 3x times 5x plus 8. So that parentheses is going to be in my answer because it can't cancel out. Now outside you got 3x, and then you have 3x to the second power. Now 3 over 3 reduces to 1 over 1. If something reduces to 1 over 1, I don't need to put anything. I'll just cancel them. Now the x's, what you do is when you have x on top and bottom, you put a 1 there, and then you get rid of the smaller one, and then you just subtract that 1 from 2, which is 1. So x is the first to just be x. Okay, I hope that's been informative, and that is how you oh no, I'll keep going, I got more. Okay. I didn't know I had more. Again, multiplication, you can just combine them. The only thing I try to factor is right there, okay? So I'm going to write 3 times x to the second on top. In the bottom, I'm going to just put that 2x, and then I try to factor the binomial 6x plus 10. So greatest common factor, DOPS. Greatest common factor is a 2 here. So it's going to become 3x plus 5, and that's not a DOPS. So I just rewrite that expression. I put 3x plus 5 times 2, and then the 3x plus 5. Okay, you got to keep your parentheses in your answer. Now on top, you got 3x to the second, and then you got 4x. Now I can't reduce 3/4, so that stays in the answer. And on the x's, remember what I said, you take out the smaller one and then subtract that from your higher one, so you still have x on top. Okay, and then the last one, I would parenthesize, that's a binomial, that's a monomial, so we just put that over. That's a monomial. Monomial means there's no plus or minus. These are both binomials, meaning they have 2 terms. But these are pretty easy to factor, both of them. So you got 3x plus 6, that contains a GCF of 3. That becomes x plus 2. That's not a DOPS, so I don't go any further. So times 3, and then x plus 2. Now the bottom, x to the second minus 4 would have a GCF of 1, but it's clearly a difference of perfect squares. So that's x plus 2 and x minus 2. Okay, we can get that out of there. And x minus 2 stays the way it is. Now you have 3x, and you have 5x to the second power. Now 3/5 can't be reduced, so we'll keep it 3/5. Then we get rid of the smaller one and take 1 away from the 2. And that'd be x to the first, which should just be x down there. Okay, see what you can do on that. If you got any questions, let me know.